So after you now had an introduction into spec, I will now show you how to actually use our compute powers, because right now, up until now, you've only used our front ends and did your compilations also on the front end, which was in retrospect not the best idea because it slowed down our front ends significantly, with everyone using, I think, 16 threads per default for compilation. That's something we'll do differently next time. But now I will show you how to actually use our compute nodes. And for this, we will use this little piece of software. The learning objectives is, first you're going to learn how to use the scheduler in interactive and batch mode, identify the right partitions and the right resources for your needs, and choose your different file systems based on their characteristics. The latter point we also discussed a bit beforehand already. Okay, let's get started. So far, as I said, you've only used the front ends. So the class is divided into compute nodes and front ends, and the compute nodes are there to do the real heavy stuff, the calculations. You cannot, however, SSH into these nodes or do any other form of connecting to them. And you're also not allowed usually to run heavy calculations on the front end. So the question is, how do I now get to these compute nodes? And the answer is the scheduler Slurm. Yes, it's named after the drink in Futurama. How does it work? Essentially, you're on one of our front ends down here, and if you actually want to then interact with Slurm, and Slurm then starts your program or whatever you want to run on our compute nodes. These are the compute nodes. Yeah, very nice. Okay, now what does Slurm need? Slurm needs essentially a few information about your job. This is, for example, the program to execute, or multiple programs, essentially a script. You can write scripts in different forms. We get to that later. It wants to know an estimated runtime, which makes it more easy for Slurm to schedule everything. Required resources, because it needs to know how many CPUs you need, how many GPUs you need, how much memory you need, and all this kind of stuff. You have a whole bunch of things that you can give as requirements to Slurm, so it can decide where to put your job. And right, so essentially, this is what I call a job. Essentially, one Slurm unit, essentially usually one calculation you do in one job, so you can think of that as a job. How does it work? Well, the easiest way to get started, not the most elegant, but the easiest way to get started is using srun. And you can just use srun and a program you want to call. I have some examples here, but since I have this terminal here, I might as well use that. So if I type hostname, then it tells me the host name of the host, the name of the host I'm on. So far, pretty self-explanatory. Now, I want to run this command on some node. So I say srun, please, Slurm, run my command named hostname. It then just send my workload, which is just running hostname, to some node. I don't know which one. Well, I know now. It sent it to AMP 012. And if I do that again, it might land on a different node, or it might land on the same node again, since this is apparently free at the moment. So let's see. Yes. Not so surprisingly. You can also, because you sometimes not only have just the name of the program, but also parameters, you can give them if you want to. So, for example, hostname-f gives you the fully qualified domain name, which is in this case this. And if I want to get that on a node, I do this and get the fully qualified domain name here as well. This is essentially a very simple way to run a program on a compute node. So what exactly is going on here? srun takes the information of your job and gives it to Slurm. These are two things. What is to be done, essentially, like the path of the required program. This is hostname in this case, and the parameters, which -f in this case, and the requirements, which I didn't give any. The thing is, we have a whole bunch of defaults. So per default, you get one node, one core on the node, I think 1 hour time limit. I would have to look it up. So I didn't give any requirements. We'll get to the point of like, we'll get to the point where I explain how to do that later. So if you give a bunch of requirements, then Slurm takes a look at the available hosts. Most of the time they are pretty full. And he essentially builds a queue of jobs that want to run and prioritized this job queue. The different jobs are prioritized on a whole bunch of different metrics. For example, how long have you been waiting? How big is the job? How long is the job? How much have you been calculating in recent times? So if you basically use the cluster all the time, you will have a slightly lower priority, so you can't just take away all the calculation power from others. So Slurm takes all of this into account, builds a queue out of that, of all the jobs that want to run on our limited resources, and then after a while, it's your turn. I, on the other hand, have, first of all, since I'm admin, I have very high priority, and I can always run directly most of the time. And also, this little job I'm running here just takes one core on one machine. These are usually pretty quick because, I mean, there's always a bit of room there for Slurm to fill it up. Right. So for now, you've only have seen one node, to be honest, only AMP012. But we have a bunch of different nodes, and these nodes have different features. To differentiate between them, Slurm uses partitions. Essentially, partitions are just groups of nodes that share characteristics. For example, I have examples here. We have our main and default. I didn't give as you can see here, I didn't give a partition. Our default partition is medium. This is essentially general purpose. Everything can run there. Well, not everything, but most of the stuff can run there. You can use up to 1024 cores per job, which is quite a lot. Obviously not on one host, but divided on different hosts, distributed on different hosts. And but for example, the maximum I think of memory is like around 370 something gigabytes of main memory you can use. If, however, you have a bigger job, you might need to go into the fat partition, which has up to 512 gigabytes in a single host. And if you have even more, you will have to go to the fat partition, which have 2 terabytes of memory per host, which is, well, just one host that has that, but still, it's a lot of memory. And so essentially, we divided our main workforce between the amount of memory it has. Then we have 2 special purpose partitions, GPU, which is for jobs with GPU accelerations. That is pretty self-explanatory, and int, which stands for interactive jobs. Essentially, you never have to wait on this queue, but there is only a very few amount of like nodes available, and also you will share the memory and the CPUs and everything on this node with other users. So if lots of people use that, your performance will degrade after a while. Okay, just to reiterate, this is mainly, we mainly talked about all this. So what is this cluster? Essentially a collection of networked computers. I think we already talked about basically everything here. So I'll skip that. That's just for if you go through the slides. Okay. We already saw our first small job, but as I said, you are supposed to give more information about the job itself, like the partition, the runtime, and others. And so you can do that by giving these parameters to srun, not to the program, but to srun itself. For example, you can use -p to give the partition or -t to give the maximum runtime. If your job exceeds the maximum runtime, the job is killed. So if you're not finished by the time you said you would be finished, then the job is killed. You might now think, aha, I'll always give the maximum runtime that is allowed, which is in our case 2 days, or with some special flags later on, 5 days. But that would be a bad idea, because the longer the longer wall time or runtime you give, the more you usually have to wait, because then Slurm has to find a slot where like your 2-day job will fit in instead of your 1-hour job. And you can easily find a 1-hour slot, but not that easily a 1-day slot, a 2-day slot. So to show you, let's say I want to run my host name. Well, we have already done that, but I now want to use the fat partition. I'll do -fat, and I'm on a different node. That's DFA001. Note that this obviously, or not that obviously, has to be before, like the parameters for srun need to be before the parameters of your program you run. You can't do something like -p fat, because then srun will think that this is part of this command and never evaluate this part. And then hostname will say, I don't know what -p fat means. I think yes, invalid option p. And the same goes for time -t. Let's say instead of I want to go the full 2 days. So essentially, you can right. The way it is, you're supposed to give the time is hours, minutes, seconds. So if you say 12:00:00, it is 12 hours. Oh. If you want to have more, you can also add time, add days. So this would run for 2 days. Again, this runs so quickly because I'm admin. Usually, it might take. You might wait for a bit. And there are different. So I've only put this one on the slides, but there are a bunch of different ways to give the time. If you really want to know all that, look into the man page. I can't list it all. And the last point that is here is not that important for this course, because you all need your use your course accounts. But if you belong to a special working group with access to special partitions, we have some extra partitions that you don't usually see, which their own hardware. You need to give the specify the all account, which is the basic account for everyone except those people, and you do it with -A all. So, for example, I could do this -A all, and I would submit under the all account. Usually my account is admin. Okay, a few more things you can do is, for example, if you want to have interactive jobs and you want to use the interactive, first of all, interactive jobs with X11 forwarding. X11 is the technology on Linux one of the technologies on Linux to display something on your screen. Not just a terminal, but like graphical user interface. But that needs, first of all, if you need to connect with SSH-Y from your local machine, and your local machine must support it. I'm not quite sure what happens if you have a Wayland session on Linux, but let's not get into that. So if you have a Mac, you might need to install, I think, Xports, and on Windows you have to use some form of some form of X server. I think there are a few. I usually use Mobile X term on Windows, or you connect via X2Go to get something like that. There are different versions, and then you can essentially start a program that opens a window. For example, Matlab, or I don't know anything else at the moment. And if you want to run something in interactive mode, you need to add PTY. Just as a, for example, if I want to run an R shell, I think that comes later, because that stays on the machine. Essentially, you need this PTY. What you can do, for example, is open a bash shell. I mean, we have a bash anyway, so why not say srun -PTY. Okay, PTY, and then bash. This will now create a job with one core on some node and open a shell for me and stay there. Now I am on AMP12, and I could take a look at what's running there. Or open an editor. So I'm now working on the node itself, which is sometimes quite helpful. For example, if you all start for example, if you all start compiling something, maybe it's helpful for the next time to do that in this way. And Pavan thankfully said it works on Wayland, and you all should know how to get X2Go working, so we're fine there. Yeah, this is an example of how to do this in with, for example, Matlab. I'm not going to do that because it takes some time until Matlab starts up, and you can try that in a minute. And yeah, so for Matlab, you can also, we have some licenses. If you all now start up Matlab, it will not work. If you want to just try an Xterm program, an X11 program, try Xterm. So there's this program, which now won't work because I'm not connected via SSH, --y. That you can run on a compute node, and this is not licensed because we only have limited license for Matlab. Yeah, this is an example how to do that, how to essentially run an R job interactively. Keep in mind what I forgot here, now that I see is you might want to load the R module first, because I'm not sure if we have R installed on all systems. Yeah, and now for 5 minutes, let's say until 16:07, you can just play around with it a bit. Try some X11 forwarding, get an interactive shell on a compute node, run some commands, just try it out a bit. And ask any questions you want to ask. Oh yeah, that's very important. The Slurm slide, Jonathan uploaded the slides I'm currently using. So if you need the commands, download the slides from the web page. Thank you for that. Yeah, the question, what is the difference again between X11, -X11 and -PTY? You need PTY if you want to open X11 is used for a graphical interface. So if you want to open a new window on the compute node, whereas PTY is used if you want to have if you don't want to use an extra window, but just want to have your console, like have a console open there. What is display variable? Well, we will. Display is an environment variable in Linux, which says which. Well, each of your it's a bit complicated. You can have multiple displays connected to one machine, and that can specify which display do you use. But this is not even like displays. I have two displays here. That's why I'm always looking to the right. but this is not even meant by that. It's like multiple sets of monitors connected. It's all a bit complicated. Yeah. It's essentially used when you have multiple sessions connected on a single server. Okay, it's 16:07, so I hope you had some. You all managed to run something on the system. If not, you can continue trying while I mean, you can all play around with it while I'm talking. So go ahead. Yeah, so I will go ahead with the slides. Okay, now I have a slide about basic concept that I actually have to talk about. The difference between different kinds of parallelization or non-parallelization in the first case. So we differentiate between serial jobs, which is essentially no parallelization at all. It means that one task or one thing is only using a single job slot, which means, in this case, a program using one core of a CPU, which is not a lot. So this is like early 2000s stuff going on. This is not in any form parallelized and not what you want to have. What you might want to have is the next thing, the SMP job. SMP stands for Shared Memory Parallelization, and is often realized in the backend with OpenMP, but not every time. You can also do the threading yourself. And shared memory means all the threads need access to the same shared memory, so they all have to be on one node. I think Julian had some slides about that in the very beginning. But what that means is every part of the program needs to be run on a single node. They can't be distributed among many nodes, which obviously has then the limitation that if you want to parallelize it, you can only parallelize it as much as you have CPUs available. On our case, it's 96 is our biggest node, so you can only have like 96 CPU. Can only use 96 CPUs in parallel, which is, I mean, not bad, but might be better. You might have with MPI, you actually have the opportunity to improve on that. With MPI, you have distributed memory parallelization, meaning that you use the MPI message passing interface, and this means that the different processes in your job, essentially what happens here is like your job gets started, the program gets started, let's say 100 times, and all these 100 programs that are essentially the same program talk to each other using the message passing interface, MPI. And so they can be spread among several nodes and talk to each other using the high-speed interconnect, the high-speed network I mentioned at some point as well. And this way, essentially, if they need some data, they can very basically ask like the other thread, the other part of the program to share the data. You will get more into how this is actually handled and how to implement MPI programs on the next day, Tuesday, tomorrow. But for now, we only need to know how to start such a program because that is important for us. And for that, you need either MPI run, the binary, or srun. Srun can start interactive jobs or just start also MPI jobs. Okay. Yes, to reiterate, essentially MPI jobs are not quite independent because they need to talk to each other, but they don't need shared memory, and use usually one core each, although this can be combined, as I come to. They are started with srun or MPI run, and in Slurm, these are usually called tasks. One task is essentially an MPI job. Nah, not quite. But yeah, I'll call them tasks. And single node jobs are usually what you do is you have one task and you have a lot of cores, which is why I usually then say they have a single task. Both can be combined, so you can have multiple tasks using multiple cores, which is then a hybrid job. It's important to kind of, it's hard to understand these, like to really get through all this in the beginning, but once you start using it, actually, it makes a bit more sense. It's a problem with theoretical knowledge. Okay, now how do you select your resources? srun and as a Slurm knows multiple ways of describing your needed resources. So the biggest unit essentially is the node. You have the capital N or dash dash nodes, and you can get a minimum and a maximum. But usually you just specify the exact number, actually. I've never seen minimum, maximum used very well. So essentially what you usually do is, let's say we want to have 2, and say host name. And what you can see, it runs the command on both hosts, AMP 22 and 12. So next thing, number of tasks. I think this is more for MPI, less for OpenMP. But if you want to have a number of, change the number of tasks, you can say, okay, I need 2 tasks on 2 nodes. I mean, to be fair, Slurm internally already started 2 tasks. But let's say we want to have 1 node and 2 tasks. And to this, then my both tasks run. So hostname runs twice on AMP12. I can also combine that and say 4. Then I get some notice that that this is not the best way to do it. I'll get to that later. You can for now ignore this. After the course, you're not allowed to ignore this anymore. After my part of the course. Okay. What can you also do? Tasks per node. So you have 2 nodes, and you want n tasks. Why is it all so long? Per node equals, let's say 3 this time. Then you get 3 tasks on my 2 nodes that are here. As you can see, now there's at least a bit change in the nodes. So you have 49 and 55. Now, this is for the case where you have multiple tasks. If you have an OpenMP job, so a shared memory parallelization, you first of all don't need 2 nodes. You only need 1 node, and you also don't need many tasks. You need 1 task. So you can say something like that, or leave it out completely because that's the default is for both as 1, and then you can use the CPUs per task. So I want to have not multiple tasks because but I want to have 1 task and 10 CPUs. I can do this and say, okay, 1 task on 1 node, but it should have 10 CPUs. Now this hostname program had access to 10 CPUs, which is absolutely pointless in this case because it doesn't need 10 CPUs, but your program might. The default for CPUs per task is always 1. So essentially what you, for example, got here was 4 CPUs across 2 nodes, and what you got here was, since you had 6 tasks, you get, on each node, you got 3 CPUs. This. Another resource you might want to take a look at is memory. You can give the memory with either the -- mem option. Say I want to have 20 gigs of memory. I do this. Or I want to have the mem per CPU option, then I get this amount for each CPU. And this time is also obviously the same node. But if I have multiple CPUs, say I want to have 2 CPUs, then I would get more. The default option, usually, if you don't do anything, there is for each partition, there is a default memory per CPU option set. You can see that if you do this and say medium, then you notice there's lots of information about here. But here you can see it's around 4 GB of memory. One thing you might have noticed is that I told you got 20 GB of memory, but how do you know? I mean, or in this case, you get 10 cores. What the hell is going on? I can't see that on the command line. You are right. And to mitigate this problem a bit, I mean, you will notice if you run a program, but for this course, you might not have real programs to run and might not notice that how much memory you use or how much CPUs you use. For this case, I have created a program called Slurm_resources. And if you run that, it says it only works inside a Slurm job, which, okay. If I run it inside a Slurm job, it actually gives you information about your job. Especially, it says, okay, each task says I'm task 0 out of 1 tasks. It begins counting by 0. For the job, each job, which I have told you up until now, has a job ID. We'll come to that later. It says where it is, which CPU. So that doesn't mean it has 30 CPUs. It means it has a CPU with a logical number 30. And how much memory. So if I do, I can see, okay, I have still 1 task, but I have 3 CPUs and my memory also grow. You should all be able to run the Slurm resources command, which will be important soon. Oh yeah, one other thing, because now you are in the next slide, hopefully. Yes, you have a bunch of exercises. And what I don't want you to wait in the queue to be able to use it, so I've created a reservation. And the reservation is called PC course. And I can't copy correctly. And what you can do is say srun. I can first scontrol show res. You don't really need to know these commands, the scontrol things, but you can see, okay, there's a reservation called PC course. There's a bunch of your users in there. That's all named HPC training something. And you have the nodes 2, 4, 6, 8, 10. Interestingly, only even numbers for reasons I don't know. Yeah, and now if I say srun, I mean, dash reservation that and host name, it will run on this reservation, in this case 002. And you are the only guys to have access to this, so you should not be able to wait, should not have to wait too long. What you can also do is, because there's no shortcut for this, which is annoying, you can set this environment variable as batch I'm not sure if it actually works at the moment. Maybe it needs to be srun for this one. I think so. Srun hostname. That should then make Slurm should read this environment variable and notice, okay, I should run in that reservation. Let's see. Yes, I think that was one of the no, it wasn't. Damn it. Does it read that? No. Ah, Slurm reservation. Okay, now that I found the right one, yeah, you could make an alias, but you shouldn't have to, because there is this functionality built in. So if you export Slurm reservation equals PC HPC course, you will automatically use it with all your Slurm commands. But if you log in and log out again, this environment variable is lost again, so you have to re-export it. Yeah, and Oh, right. And if you want to use anything besides medium, all my nodes in here are medium nodes. So if you want to try the FAT or FAT plus partition or GPU interactive, you have to unset the variable or take out reservation. So yeah, keep that in mind. Now I want to want you to try a few different job configurations, tasks, like how to distribute tasks over nodes, multiple cores, mix everything up, add some memory stuff, play around with, like, take a look at how Slurm works, essentially, how it allocates the memory. And you can use my Slurm resources script. Yeah, please, we'll have 20 minutes. If you need a short break or something, I'll get some water, actually. You can do that now. So yeah, see you again I will be here at earlier, so I'll be here at 6:35, 4:35. Actually, I'll be here the most of the time. So if you have questions, just ask me. I'll just be gone for 5 minutes now. Okay, I hope you're all done with everything and had a moment to take a break. I'll go through these exercises really quick. So essentially, no, that doesn't work. Slurm resources, and I want to have 10 tasks, would be N10. And you can see you get a lot of output because each program, you start the program essentially 10 times and each prints to the screen. If you want to distribute it over 3 nodes, you can do this. You can, I'm pretty sure, yeah, 006, 004, and the rest is on 002. As you can see, not equally distributed. If you want to have 3 nodes with 3 tasks per node, you do this. Div 3 on 6, 3 on 4, and 3 on 2. 1 task with 5 cores. Dash N1 dash C5. You can see it has CPUs 0 to 4, so 5 in the end. And now the combination of everything. 2 tasks per node on 2 nodes, and per task 4 cores. I have 2 tasks per node. Very good. 4 tasks in the end, each on on 2 nodes, and each one has, as you can see here, each task has access to every node, every CPU on the host. So you have each task has access to 4, but then in the end we have 4 cores per task. So that makes sense. Now the same. Not the same, but similar with memory is --m, let's say 4 GB. You can see we have 4 GB. If we don't do this, we hopefully don't have 4 GB. Right, only almost 4 GB. And now you can do the second one, 3 tasks, and 3 and 2 nodes, and say --mem, I want to have 4 GB. Let's say 10. That's a nice and round number. I want 10 GB. Yeah, that too. And so in this case, you see these tasks are on number 2, and this is on number 4. But so these tasks share 10 GB of memory. This task has 10 GB of memory alone, which might be what you want, or it might not be what you want. But if you want to have it per CPU or per task, no, only per CPU, then you could do mem per CPU, which would lead then the first host with the 2 tasks on it to have 20 GB of memory available, and the second one still 10 GB. Okay. Now, for now, we have run everything as an interactive job. What that means is we have to stay logged in. So if we want to run something that takes ages, you have a bit of a problem, because either you have to keep the your terminal open, and SSH does sometimes disconnect, which is not good. And it can go for days. It's not an ideal solution. You might now say, haha, but how about screens or TMUX, terminal multiplexers, which can work around some of these problems? Yes, that would work, but there is a better way, better reproducible, and the way batch systems are usually used, which is called batch jobs. Essentially, scripts that interact with a batch system. So what is it? How does it look like? Essentially, you have a basic bash script. And this is, or shell script. It doesn't need to be bash, actually. Basic script that has a specific, very special comments in the beginning. These comments for Slurm start with sbatch. First, they have to be, like, the first is the one I think was already explained by Jonathan, is essentially telling the interpreter that it should run as bash, the shebang line. And then next definitely need to be the sbatch lines, and these take the usual arguments you had before, like -p for medium for medium partition, -t for the time, and some new options. And if you put them there, Slurm will actually read that before running the script. No, it's also bin bash is fine as well. There's a question. Shebang should be user bin bash. That is, I mean, technically maybe correct. The thing is, nowadays bin bash is bin is usually symlinked to user bin anyway, so it's the same. And I've learned it with bin bash. That's why I always do it. But user bin bash is fine as well. Back to the topic. So it evaluates these. Slurm then reads these lines and evaluates the same way that we previously did it on the command line here. And yeah, let me quickly have a job.sh. Yes, okay, fair enough. Oh, there is already one. Let's delete that. Okay, say we have a new job script. I have too many old job scripts lying around in my home directory. So we have this bin bash, or user bin bash works as well. And we say sbatch-p medium and -t. Yeah, okay, I'm going to go. If we just have two numbers, Slurm evaluates this as minutes. That is important to know. If you can't remember that, always give the full. This should also work, just to know for sure what it's going to be. And yeah, let's do this. I'm going to explain the job thingy, the last line later. So resources. I think no. Yes, no, yes. No, keep it that way. And then you can submit it with sbatch and the name to the job script. Now, what happens is you get a little notice that tells you submitted batch job, this, and you get your job ID. Each job gets a consecutive job ID that is system-wide, so we are at job ID, I don't know, a large number, too large for me, I can't count that high. And then if I say, okay, let's see what happens, you get a file in the end that is, for example, Slurm and then dash the job ID, .out. I can look into that, and all the output that is usually put into. Damn it! Why didn't it work? Okay, all the output that is usually written to the standard out to the console is then caught in this batch script, plus some extra options that are like this part is in there. Some extra information, and here is some extra information. For some reason, the actual output should be between this line and this line, and it's nowhere to be found, and I don't know why, which is annoying me. No, god damn it. Did I mistype that somehow? But then it should have an arrow. Oh, that's completely right. Just to be sure, I'm going to delete this again. Now it's there. Ah, wait, was I blind? Oh, sorry, I think there were too many lines in the previous one, and I just got confused by my own scripts. Yeah, this is actually the output of the script, so everything went fine. I'm just blind. Sorry about that. Good thing we were recording this. Now, this is the output of the job. It's written here. Then we add from the scheduler, we add some meta information, as I said, your user, your account. So just something it's nice to have in your job script, so you know you can check that if everything went as you expected it to be. These are sometimes, if you have like a job that only runs for half a second, these are sometimes wrong, the job information, because it's too fast to be evaluated correctly by the job scheduler. If you have a real job that runs more than a second, this will be correct. Just ignore it for now. Right, so what are job scripts? Essentially, they are normal scripts. You can also use different scripting languages. There was last time some problems using Python. You could theoretically do that, but I would need to look it up myself. This is a bit more complicated. Usually what you do is you use shell as a normal shell like bash or the sh shell. Yeah. And the thing to remember is the SBatch lines need to be at the top. So they need to be before you, before any other. If you do something like, just to be sure, this is what you should not do. There can be as many empty lines and comments. This is not a problem. More empty lines, not a problem. But something like a equals 10 would not lead to an error. That's what confuses. It was usually confusing here. This is not an error, but Slurm doesn't read that anymore. So your SBatch parameters aren't completely correctly set. Or if you do something like echo hello or something. So always remember, put them at the top. What can you do in such a script? Yeah, essentially everything you need to do. You can copy files to some directory. You can load your models. You can do scripting. You can write your usual scripting. It's a normal bash script. Yeah, and it runs on the node you are running on. For MPI, you have to use srun or MPI run to start your program. In this case, because you have multiple nodes, then you might have multiple nodes. Then there's usually one head node designated that you can actually, I think, find out in Slurm. But yeah. Right, here's the options that we here's the options that are given that we have. So we have SBatch, then some Slurm options, and the job script. These are the same parameters you can use in the file or for srun. Well, most of them anyway. And if you say put something here on the command line, it overrides anything in the job script. So this basically the precedence order is the most important thing is on the command line. The next is in the bash script, and the least important thing is our environment variables, which we for example use for the reservation. Now, if you want to reuse the reservation, I recently said this variable and I have it on my slides. Apparently, Slurm has two different variables. For srun, it uses Slurm reservation. For SBatch, it uses SBatch reservation. I find that silly, but it does. It is how it is. So yeah. Some more options that I wanted to mention on this slide is if you want to have email notifications. For example, when your job begins or ends, there's a bunch of more notifications. You can look into them. I'm not going to go through them, but they are in the man page and quite well defined. If you want to get that kind of notification, please put -- mail type equals the type you want. For example, begin and end. That would be s batch -- begin. Actually, let's do that in the job. You could do something like s batch -- begin equals mail type equals begin, comma, end, and then you would get a mail at the beginning and the end. But it only works per default. It works for your username at gwdg.de. So it works well for me because that's my email address. It might not so well work for you because you have course some course specific email addresses. So what you have to do is give your email address as mail user. So sbatch mail user, I don't know, move at gwdg or whatever you have at Gmail. Fail. Very good. That's what I wanted to type. Any email address you can put there. And then also what you just saw. Wait a second. You can also give the place where the output should be stored. And you can do this with -o or -e. -o is the output. -e is the error. So any errors go to the file set as -e. Everything else, normal output, goes into the file you denoted with -o. So it usually goes to Slurm job ID. So the job ID will be replaced with the actual job ID .out by default. You can change that. For example, you could do something like sbatch. As you can see, the order doesn't matter. And course J, and that's it. You don't need a .out ending or something. So if I now submit sbath, yes. Getting late. Now this will be in course, then, yes, exactly, this one, course - job ID. The second half didn't work so well. That's the problem with the very short jobs. If you don't give an -e, it will go to the normal output file, by the way. So you don't have to give that if it's supposed to be in one file. Now, what we did, so far, I only showed you how to submit jobs. And you might also want to get a bit of information about, like, what jobs have I currently, so what are my jobs currently doing, if they're still running, or I want to cancel a job, or something like that. For that, we have some Slurm commands. We have lots of Slurm commands, but I'll start with these. The first one, as info, essentially shows you information about the current system and its partition, like how much, what is going on. If I do this, I get a lot of different partitions. You will not get these. Can I do this? No. Too bad. So you will get a lot less. It's a bit more, not as chaotic as this one. But you can also ask for a specific partition. So let's say I want to know what's going on with FAT+. Then you see, okay, we have the partition FAT+. These are available. They are up and running. The time limit is 2 days. There are 5 nodes that are in state mix, which means they have some resources left, but they have jobs running. And then we have, this is essentially saying, okay, one of these nodes is allocated. Allocated means alloc for allocated is completely full. There's nothing going on there, nothing fitting on there anymore. You can also say, I want to have a summary of this. And this gives you essentially a summary. So for you, it will be more like medium, fat plus GPU int. These are the, you can see by default, you can see these. And you can see, okay, the summary is on FAT+, most of them are, this is now AIOT, which means allocated, idle, other. So in some error state usually. It's not a good sign if there are too many nodes in O. And T for total. So you can see 6 are allocated. That doesn't mean they're full, just that they have some workload. There might be some more space on them, but yeah, they're used at least. And we can see here we have 163 nodes in total, and 10 of them are currently unused, and the most of them are not. I guess those are our 10, most of them. And the same for all. You can also filter by state. You want to have T. I think you can alloc. Then you see all the allocated nodes, which is a lot. Okay, SQ shows the currently running jobs, which is, again, a lot. If you want to see only of one partition, let's say fat plus, this is a bit less. You can see, okay, there are some running. Then there's 2 different kinds of waiting settings. You can either be, there's a bunch of reasons that are possible, but priority and resources are pretty common. Resources means it's on top of the list of, at top of the queue, and it's just waiting for resources to be free. Whereas priority means, okay, I'm not at the top of the queue, I'm waiting for me to have the highest priority. So if you see this for your job, you're next. If you see this for your job, you're not next. And if you only want to see your job, you can just say -- me, which in my case isn't a lot. If I now do sbatch, and if I go into my job and say sleep, which does what you think it does, it puts the process to sleep. I can do sq -- and you can see, okay, my job with this job ID in partition medium, job name. The name is usually just the name of the script. You can change that with some parameter that you can look up in the man page. I don't know that by heart. You can see the state. Right, the state is usually running or pending, for example. The time it ran, the nodes, and so on and so forth. Ah, yeah, and you can cancel something. The easiest one is cancel, and I just cancel this, check, and now it's in state, oh, well, that's good, completing. That usually takes just like a second. It's lucky that I got it. Sometimes it takes a bit longer, that happens. But this essentially means it's just cleaning up after itself. And yeah, then it should be done now. You can only cancel your jobs. You can also cancel all your jobs on a partition, or you give your user ID and cancel everything from your user. I will not show that because I can actually cancel all the jobs of a partition, and I think people would not be happy about that. Okay, so I think the schedule of this course says we should take a 5-minute break now. I would combine this with an exercise. So let me just go through this exercise shortly, and then I think that should work out quite fine. Like, you can take 5 minutes. Okay. I don't know how badly you need coffee, though. But let me go through this first. So exercise is you should write your own JavaScript. Use echo hostname and sleep to have some output, or have it run for a longer time, because otherwise it's kind of there's not much to see in such a JavaScript. You can also do some scripting if you feel like it. Try out to have the job send you an email. And if you are already done and bored, you can also take a look at the different mail type options. Look into the man page of sbatch and see what do they do, and try them out. Yeah. And please try to write your output to a different file, not just slurm-jobid.out, but do something else. Try to redirect output and error to different files, so use -o and -e. And you can do that by just mistyping a command, essentially. So you need to create some error, obviously, which users are very good at. No, you just need to mistype some command, and it will print to the error file. So if I do something like echo instead test, it would say I don't know echo, because it's not a real command. And then it would automatically write that into the error. So something like command not found. Yeah, that makes sense. If you also have some more time to kill and want to take a look more, please have a look at the file name pattern option. That is, it's also named, described in the man page. You can look how to actually include for example, the node and the job name in the output file. And while you're at it, why not change the job name as well? I mean, yeah, and I think that's it. Where am I? 30 of 34. That should be fine. Yeah, let's do now 20 minutes for that, and I think you should be fine. You'd be fine and have 5 minutes of that time also for break. So I hope that's okay with you. So we will meet again at 5:25. And by that I mean I'll again stay here most of the time, because where am I to go? Okay, let's continue. I hope you had some time for a break and also enough time to solve this exercise. Let's go into the last block. Yes, first of all, there's this. What now comes is we have a bunch of different stuff that needs to be addressed in some form that does sometimes seem a bit arbitrary, but things that we need to talk about. The first one is task distribution. You can see here an example job script that is essentially having 240 tasks somehow distributed and was spread among many nodes. What does it do? It purges all modules loaded, loads some modules, runs some software. Never mind that. It's an MPI job that is spread among many nodes. This is not ideal. This one would be more ideal. So this would say, okay, I want to have 10 nodes with 24 tasks each, which is essentially, this means it fits on our older nodes as well. It doesn't only fit on the big nodes, on the AMP nodes. Then it does essentially the same. And you might think, well, I mean, there is not much difference. It's got 240 cores no matter what. But if you pack it as tightly possible on as little nodes as possible, you have the advantage that MPI doesn't have to use it is extremely quick. The interconnect is very fast, but there's nothing faster than memory. Well, okay, cache, but like we don't have any faster technology. In this case, memory is essentially the fastest we can get. So you should always try to pack it on as little nodes as possible, because even though the interconnect is fast, memory is faster. Now, one more thing, the disk space. I already mentioned that in the first talk I gave. We have different options. I've talked about them. I said we had local disks, and in Slurm now sets a, well, not Slurm, we set a specific variable called TMP local for each job. This is a specific directory created for your job. This means it will be deleted afterwards. Also, the whole local system has automatic file deletion. So if you keep storing anything there, it will delete it at the end of the job. But you can use, specifically for temporary data, you can use temp local. So for example, srun --pty bash. I can say echo, you get TMP local. And this is at local jobs and then the job ID. And after whatever I write there, echo A into test. This is now a file there that has A in it. If I now end the job, the file will be gone. You have Scratch, which is as I already said, shared. There's no backup, no automatic file deletion. It's very fast, and so on and so on. I already explained all that earlier. You have to specify. You should specify if you are on Scratch 1 or 2. So with Scratch, if you want to have Scratch 1, you can use srun dash or sbatch dash c Scratch. Oh, Scratch, and then say host name. This means okay, I'm gonna get a host on a node with Scratch access, because if I look at it with this is essentially Scratch 1. You can see this is a symlink to Scratch 1. If I'm coming, for example, from the other, if I'm working on the other data center or the other location at Fassberg, then you will have Scratch 2. So if I would go to, yes, for some reason this still happens. Typing is hard. This points to Scratch 2. And if I create a file here, it will not show up on Scratch 1. So what do I do to make sure my job ends up on Scratch 2? I say Scratch 2. That's all. Then suddenly I get a DMP node, which has access to Scratch 2. Did I ever say Scratch 1? No, that I should do at some point. But never mind that. Now, I'm going to go back to the other thing again. If you try that and have the export with the Slurm reservations thing set, then it won't work, because the Slurm reservation only has access to Scratch 1. So something to keep in mind. Then we also have temp Scratch with the temporary directory of Scratch. Same deal applies with Scratch usually, only it is supposed to be SSD backed. At the moment it isn't, but it will be again. So we have it's ideal if you have temporary data that is across multiple nodes. Some jobs need that, and if local is if you don't fit all your data on one node and all the jobs on one node, it's perfect for that use case. We had some problems with the SSD backend there, but we will replace it. We are working with the vendor, so hopefully soon we'll be there again. You can still use, even if it's not available, the SSDs are not available right now. You can still use temp Scratch for temporary data spanning multiple jobs, multiple nodes. And then home, yeah, I've already explained home. Here's an example what you could do using in a job script. So this is a Gaussian job, a quite old one of Gaussian 09. It does some stuff that Gaussian needs to set up, and essentially what we do here, we check, okay, does temp Scratch exist, which it should, but just to be sure. And as a directory, then we set the SCR dir, which tells Gaussian, the software, that it should put the temporary data of Gaussian there. And we say, okay, set that to temp Scratch. If this doesn't exist, okay, try local, try temp local. And then we just do the usual calculations. Yeah. If you have anything in these directories at the end of the job, it will be lost though. So if you want to have some kind of checkpointing, or if your software writes checkpoints or something, please keep in mind that you need to save them before the job ends. And now we have another small exercise again, but I want to do that in the end because I'm not sure how much time we will still have. It's essentially a small job script writing exercise. You can do it on the side, or we'll see if we have time in the end for this. We should, though, hopefully. Yeah, we'll see. Now, I have a few notes on the FAT Plus partition. The FAT Plus partition contains overall 6 nodes. One node with 2 terabytes of memory, which is GWDE 001, and 5 nodes with 1.5 terabyte. Generally, if you want to use them, fine. I mean, that's what they're for. They are expensive, though, if you think about it. Like 1 terabyte, 2 terabytes of memory is expensive, and many people want to use it. So please don't just start using these. And yeah, just don't start using these immediately. If you think you might need more memory, have a look at what you actually need. Is your job out of memory? This is why I was didn't say immediately just take a large amount of memory and see if it works, but because then people will tend to stay there. So what you can do is you start essentially, okay, you notice I don't have enough memory. We'll come how to notice. We'll come to the through a way to notice that, to tell when you run out of memory. But you notice, okay, I'm out of memory. What do? I start on the fat partition and request more memory. And then you run out of memory there as well. Then try the fat plus partition. So don't just go like, I'm out of memory. Okay, I'm going to the fat plus and request 2 terabytes of memory, because that might waste quite a lot of memory. And I wouldn't even be mad if you do that once and afterwards scale it back. But some people just in the past did just ask for 2 terabyte because it was there and not because they needed it. It is kind of annoying. I know that there are specific cases where it's hard to tell how much for each run it will use. There are exceptions to everything. So you can use sact or Profit HPC. So sact is a Slurm built-in tool. Profit HPC is a tool we have installed and we've developed in a project. And to see if if your memory is really at the limit. If you kind of unsure and need help, just ask us, because that's what we are here for as well. If you want to use the fat plus partition, the memory, there's a Y missing, or mem per CPU, so some kind of memory option is mandatory, otherwise you will be per default sent away. And if you waste the resources here repeatedly, I might contact you in a very rude tone. No, obviously not a rude tone, but I might be annoyed with that. Right, so should be something that we do after the OpenMP task, but anyway, I've hinted at hybrid jobs, so jobs that do both, have multiple tasks and multiple CPUs per task. And this is just a small example of how something like that might look. It might be interesting later on when you actually do start programming MPI and OpenMP. For now, let me tell you that after you can say, like, for example, you want to have 4 tasks per node, and then each task gets 6 CPUs. So you're at 24 again. And you want to do that over 5 nodes. So yeah, that's quite a big job. And what the interesting part is, OpenMP, if you use OpenMP for shared memory parallelization, it usually reads this environment variable, OMP num threads, which is the number of threads that OMP uses, quite aptly named. And you can use this variable, Slurm CPUs per task, which, as it indicates, is set in this case to 6. So it's set to the CPUs per task. This way, essentially, you will start 4 times 5 times this with srun, just parallel executions, and each gets 6 threads, and knows, thanks to this variable, actually knows about these threads as well. If this confuses you at the moment, I'm sure at some point when you work with it and when you actually use OpenMP, it will make more sense. Now, you sometimes may be interested. So for now, all the maximum runtime was 2 days, but there are jobs that need more than 2 days, and I don't like that, but that's the reality. We try to limit the maximum runtime as much as possible because it makes administrating the cluster more difficult for us. But yes, we see that there's a larger runtime sometimes necessary. So for that, we have a QoS, a quality of service, that you can give with the QoS parameter. There's, first of all, let's start with a short one. For short jobs, you can give the QoS short. For jobs that maximum 2 hours of runtime, this has a higher priority than normal jobs and limited job slots available. So you can't have like 10,000 of these jobs at once. That won't work. And then there's the long option. So if you have more than 2 days of runtime, you need to give the long options. Again, there's limited job slots for that, just to encourage the main usage. So if I say quos equals, let's say short. So usually I'd say, okay, I'll do that for a 30-minute job. That's not quite correct. 30 minutes. Sleep. No, I don't want to wait for that. I just type hostname again, the usual. It works quite well. You don't see the difference in priority on the command line at the moment, so you can trust me, it had a higher priority. What happens if I say, okay, but I want to have it 1 day in 30 minutes? That's not how it works. Okay, let's say 12 hours. And it should run in the QoS short. And then it tells you, job is too long for QoS short, maximal 2 hours allowed, unable to allocate resources. This is the main thing. Request a time limit is invalid, missing, or exceeds some limit. Yeah, so you can't do it with a longer job. More interestingly, if you want to have, like, more for the most people more interesting, the long job. So if you have a job that runs 5 days or less, I mean, try to be realistic, but I'm going for the maximum here. If you want to have a maximum 5-day job, you can say, okay, use the long QoS, and it actually runs. If I take that away, why does it say no? Doesn't it say no? I think it is now. Let me do this here. 4 days, whatever. sbatch -q long. Now it runs. Okay. I'm not quite sure what happens what happened here. No, don't know. Our reservation isn't okay. The reservation I'm using isn't that long, so the reservation is only 4 days and a bit, because the course is not 5 days anymore. And so it tries to run a 5-day job on a 4-day reservation, and that won't work. Whereas the 4-day job did work, because that still fits. I think that was the issue. Okay, but now for the other part, what is my job even longer? First of all, is the basic answer, try parallelizing it even more. That might sometimes be possible if you write your own software. Sometimes you are at limits where more parallelization doesn't make any sense. Then next thing would be, or another thing would be to break it down into smaller steps. So you can have, like, first step 1, then new job for step 2, and so on. There are ways in Slurm to build dependency change, so you don't need to do that like step by step, but can have one long dependency, and it runs in different jobs. Sadly, I don't have time for this today, but, well, I have some documentation on that. Then next, if you don't write your own software, or even if you write your own software, think about checkpointing. Checkpointing is essentially writing the current state to the disk to reload from there and start again. So some good software does support checkpointing, or, I mean, if you can somehow implement it if you write your own software, also good. Check again, yes, that's there, because sometimes people tell us, no, that's not possible. Then we read the documentation and suddenly it is possible. Yeah, and if all fails and it's not possible, you're not writing the code, and nothing else is possible, contact us. We can help you. I mean, there are ways to let you calculate longer, but we're rather hesitant to do it. As I said, it makes our job significantly harder, and if there is some outage, you lose a lot of calculation time, because nodes tend to crash sometimes. Okay, some more Slurm commands I want to show you. I've already used scontrol a few times. You can essentially show things about entities, about partitions, about nodes. You could show node AMP002, and you can see which features are available. We have features like Cascade Lake, which is a computer architecture, the location, MDC, Scratch, local. I think by now every compute node has a SSD, so the local every thing has the local feature. But well, and you can see the real memory. Lots of information in there. Then you could have a look at the partition. I already did that to show partition fat plus. You can see, for example, okay, it has default memory per CPU is almost 40 gigabytes, or other things. You can see which nodes are in there, who's allowed to calculate something. It's like, as I said, lots of information. And one last thing, you might think, hey, I can get information about the job. That is correct, but only for a short amount of time. So after like 5 minutes after it finished, Slurm will purge the records from scontrol and put it into a counting database, which we will look at here. Yeah. Then right, but you can still get some information while it's still in here. You can, for example, see, okay, where does it put the data, like which working directory, the command it used, the standard error and standard out, and stuff like that. Yeah. Now, Esprio shows you the priority information, which is not exactly easy to read. Essentially, first, what you want will be less information. So this would be the medium. And what you get is, oh, that doesn't even fit on this. Okay, let's make it a bit broader. For all the jobs per default, not even the user, it says what is the priority. What you can see here is, for example, if the age goes up, this factor goes up as well. This one has quite a high fair share. I'm not quite sure why that is, but I'm sure that is correct. And some of even more fair share. That might be me, though, because I'm admin. Yeah. The problem is, as I said, it's a bit complicated. I have a few notes on that. Also, again, in the Go HPC coffee, I had some notes on Slurm tips and tricks, and there's some more information about using Esprio. If you really want to look into this, go for it. But in general, you can usually trust Slurm to do it right. So yeah, and by usually I mean always. Sometimes hard to know why you have to wait, but Slurm is always right. Now for the more important part, you can use sact to get information about jobs. So let's say I want to, after 5 minutes, this one will not be in scontrol anymore. You can only see it as act for accounting. What you can see here is essentially some information about the job. For example, the job ID, job name, medium, blah, blah, blah. It's all nice and well. You can say, okay, I want to have long output, which is really long and has a lot of information about the job. And the thing is, you have what you can see here. You have like one job ID, then you have the so-called batch step and the extern step. And you're wondering what it is. So the batch step is your job script. If you, in your job script call srun, you will get a step 0.0 there. And for each srun call, you get another 0.1, 0.2, and so on and so forth. And extern is something specific. When you SSH into a node, then it will be calculated, it will be accounted for there. Now, the interesting thing is, you might want to use, is max RSS, which is I think that's on the next slide. Oh, it's later, but which essentially the memory that your job needed. But since it's on a later slide, I'll get to that. One thing, as act has lots of options to show, and you can specify it with the -- format option or -o, and you can see all the options with as act -e. So as you can see, there's lots of information. So if you really need to dig in on what happened on your job, this is a good place to start. But I think I could fill about an hour with all these options. Before we, okay, I should maybe put that the other way around. But one more thing again is GPU usage, because there was already a question about GPU usage, although that one on Jupyter notebooks. We have the GPU partition, but if you just say srun -p GPU UI bash, then you don't have any access to the GPU. You now have, why? I think because I'm admin, I'm allowed to do that. You shouldn't even be allowed to not request a GPU. Yes, very good. If you're a normal user, you will not be able to, without a GPU specification, to use the GPU partition. How do you specify GPUs? It's pretty simple. You start with just G or -s GPUs, and then the number as the simplest part. Then you get actually somewhere, and I am so. Okay. Then I now have access to one GPU. What kind of GPU? That kind of depends on which node I am. If you want to have a specific GPU, you can tell that. So, for example, if I want to have I can give the type here. So I could say, okay, I want to have an RTX 5000, which is a nice GPU. Then I have the colon and the number of GPUs I want to. Now I'm on a different host because this is on the AGQ, and I will have access to one RTX 5000 node. I can verify at least the number of GPUs by looking at the CUDA visible devices, which says in this case 0. It will always start counting from 0 because that's mapped internally somehow. And if I module load CUDA, if I load the right drivers, I should be able to have NVIDIA SMI, which essentially shows me the current, it's like HTOP or top for GPUs. Not quite, because it's not you get some information about the GPU. Anyway, so I can see I have a Quattro RTX 5000, and I don't really use it at the moment, obviously, because I only have a shell running. You can also use the GPUs per task and GPUs per node, which do exactly as it says on the tin. And if you want to see all our available stuff, GPU-wise, you can use this neat little trick with -- format, number of nodes, number of GPUs. And then it tells you, okay, the AGQs have 4 RTX 5000. You can ignore this. This says something about the sockets they are on. Our AGTs have the V100 nodes, and then we have some more. Some of these are actually, no, all of these are available for everyone. So, yeah. And then you can do with them what you want. Have fun. Now, some last words on debugging. Essentially, usually we don't hear from our users until something goes wrong. So I'm trying to avoid that by giving you more options on how to actually debug something. The first thing you should do or could do, however you like it, is take a look at the output files that are written while the job is running. So you submit a job, and then the job continuously writes the output that usually comes to whatever path you gave in SBatch. And you can use, for example, tail -f. To -f means follow, so it essentially puts, if Slurm writes new stuff or your program writes new stuff to the file, it will also appear on your screen, which is you can live debug it essentially, and you see when happens what, and so on and so forth. Next idea is, okay, I have a job. Let me create a job again. Let's do 5 minutes this time. Also not this, and also not this. Sbatch job.sh. Now, there is a job, and I want to take a look at the node. What the hell is going currently on? Why would you do that? For example, to see if the calculation actually runs, or if something went wrong beforehand or afterwards. Are you using all the cores you have? So you can take a look at --me at where it's running. Now it says to me, okay, AMP 12012. I go there and it says, well, what is going on today? I can't SSH between systems. So if you have a job on the node, this should actually work, as well as, I mean, this that previously didn't work. I'm very not happy with this. Let me add that. Okay, now I can do that again, which is not how it's supposed to work, but I'll take it. Annoying. Anyway, now I'm on the node, and I can just, for example, look at htop to see what the hell is going on. Since my job doesn't calculate anything, it will not really show up on the top usage here. So anyway, you could now take a look. You could, for example, what you can do is with you can limit to 1 user. I pressed U, now Boden, enter, and what I can see is essentially I have the sleep thing, I have an SSH daemon running, I have a shell running, which I'm running this in, and I have this htop running and the Slurm job, which you can see bin bash and Slurm copied my job script to var spool slurm d job blah blah Slurm script, and it's running there. And what is running? It's just sleep. Okay. Next, take a look at the extra output we give you. This is there for a reason, to check, like, okay, job ID might not be that interesting. Account, is that the account that I wanted to use? For most people, it will always be all, so meh. But you can see, like, okay, was the partition correct? Did I want to put it into medium and I did something wrong there? Which is essentially what's happening if you have, for example, something on top of your sbatch directives in your job script. For if you have echo 1 and put fat plus here, then you would see that this job would land in medium because it's the default partition, and that you could see that by looking at whatever partition says here, because like just have a look at it and see you can see the job list and how long it ran and so on and so forth. Essentially, what I'm trying to say is, like, is this actually what I expected the job to have? Maybe something went wrong in the job script. That is something you can read here. Then next, try to read the errors that you get. For example, I've had more than once someone sent me the error file and there was something like this in it. Detected, well, this was a bit much more than usual, but detected OOM kill events. Some of your processes may have been called by the C group out of memory handler, as run in this task out of memory. This, well, hints at the fact that there's something wrong with the memory and you don't have enough memory. And if you read carefully your errors, you can see that. And what you can do, for example, to check this, and this is something Julian hinted at before, you can take this command, for example, put in your job ID, and see, okay, well, this is a bad example because I think it's still running. Okay, it only works afterwards. Need another job. I don't have another job. Damn it. Okay, let's cancel this so it's over. And then it should, right. Now, it actually shows you, okay, the max RSS is essentially how much, it's the high watermark, like how much memory has ever been used in this job. And it says, okay, it doesn't say it for the first, like the overarching step, but it can tell you for each other step. So if you only have only run a batch script and no srun commands, it would be this one. This is interesting to see in this case because the SSH session, when I SSH'd into the node, this will be in here. So you can see that I actually used more by SSHing in that as compared to just running sleep, which makes sense. But if this now says, for example, I think it will always be displayed in kilobytes, but if this, you can calculate it obviously into some gigabytes. And if you say like, oh, this is a bit much, then this is a good first step to take. Like, check if this is actually what you, if this is too much for the node. Check which node you're on. This is the max RSS node. It says which node this occurred. And check if this node has enough memory for that, or if that was the limit. If that was the limit and you have errors like this, increase your memory usage. No, allocation. Request more memory, that's the way. And last but not least, there's also Profit HPC. Profit HPC needs at least, I think it was a runtime of an hour until it's in the database. So I don't have anything, but I have a very old job that Azad always used, to a colleague of mine. So I'll just, this essentially simulates this. So you will get an output like this. So essentially, you have again lots of meta info. So job ID, partition, requested compute units. It's all very self-explanatory. Then you have the CPU utilization. The mean value is in high watermark, essentially. So you get on each node, you get how many cores did you have, how much CPU did you use in like the mean value, the average, and what was the high watermark. In this case, of course, if the mean value is 100%, then the high watermark will be 100%. And for memory, it shows you again the mean value and the high watermark. So here's at least some difference. You can see like, okay, 0.59 gigabytes and 0.6, at least some difference. And it tells you how much did you ever actually have. You have, in this case, you had 20 gigabytes of memory. You only use 600 MB. Yeah, kind of a waste. But this is not even that much of a waste compared to other jobs. So, but still, if you might think about reducing your memory usage, and you get all of that for the total for all of that. The same holds true for your GPU utilization. You get again mean value is high watermark for the GPU usage, and also the corresponding processors. So the bus ID, which of the GPUs on the node you get, the mean usage in this case was 1%, at maximum 4%, and only 4% of the memory. So in the end, this was not really. So you had like this job had 6 GPUs, but used them very poorly. You also get some information about your input-output, so file system write and read. So read in summary, scratch information. So and InfiniBand, how much did you use the interconnect? I guess for the newer ones, it should say OmniPath. And then some node description, like just for you as information, what kind of node was it actually? Keep in mind, if it says available memory, that's or the cores, all of this is for the whole node, not what you allocated. And in the end, it gives some recommendations. For example, in this case, like if it can be automatically generated, so it's not going to be too in detail. But for example, in this case, it's quite easy to see, okay, the mean usage was 5%. Even the high watermark was 5%. The mean usage was 1%. So yeah, all GPUs have low GPU usage. Might be some misconfiguration. Have a look into that. Some GPUs have more than one process running at the same time. Okay, yeah, I think that's what's going on back here. The processors per GPU and the usage of them. So it gives just some general recommendations. And now it's 18:02, and I'm on the last slide. So yes, I think that's it. Good thing I skipped the last exercise. Right. That means that that's it from my side. If there are any questions, I'm happy to answer them.